So what I want to show here is how the way you structure your data can change the way you have to structure your instructions. We tend to think when we program about our instructions mostly, we think about the statements, the controls, if, the loops, for, while, those sorts of things a lot in an imperative language like JavaScript. But the way you structure your data is tied in a really important way to the instructions that you provide. If your data is organized well, you can write much more concise, compact instructions that are easier to maintain and easier to read and understand. So let's take a look at the code at the beginning here. I've set up this code that draws 5 circles on a gray background. The location of the circles are stored in individual variables. Rx is 100, Ry is 100. Down here I change the fill color to red. And then I draw an ellipse at Rx over, Ry down. It's 50 by 50. That's this one. Then I change the fill color to orange and I draw an ellipse at Ox, Oy. Then I change the fill color to yellow and draw an ellipse at Yx and Yy. So I'm drawing all of these with values stored in individual variables. Because they're stored in individual variables, JavaScript doesn't really know that these variables have any special relationship to each other. So we can't take advantage of the relationships between them, since there aren't relationships, to make our instructions smoother. So if we store our data a little bit differently, we can start to collapse our instructions. One thing we can do is, instead of having Rx and Ry be independent variables, we can create a little object that has an X property and a Y property. It would look like this. And then we could say r.x, r.y, and it can still understand that. Now, JavaScript understands that x and y are related to each other. They're not two independent variables anymore. They're two properties of the same object named r. We can do that to all of these variables. Okay, now we have a red object, an O object, a Y object, a G object, and a B object. We can change how we access those values down here. All right, so this isn't really that much different. It still works. X and Y's are now paired up and they belong to particular objects. But the code's more or less the same. We're really going to see a more dramatic improvement into how our instructions work when we turn this into an array. We have these 5 objects that all have the same format. We can make that into an array instead of 5 independent variables. It would look something like this. So now we have an array with 5 dots in them. We no longer have a name for them. There's no more R, O, Y, G, or B. They're just 5 ordered dot locations. These are just an array of points right now. So I can't refer to them by r.x, r.y. I'd have to refer to them like this. Dots 0.x, dots 0.y, dots 1.x, dots 1.y, and so on. At this point, I'm seeing that this repeated code, I could probably turn this into a loop. Let's try this. There we go. So now we're looping through this array of dots and drawing each of them one by one by one. Since there's 5 dots in the array, we're going to loop through this loop 5 times. The first time dot will be the first thing in the array. The second time through, dot will be the second thing in the array. The third time through the loop, dot will equal the third thing in the array, and so on. Of course, now they're all drawn in red. That's not what we want. What we can do, though, is move the color into our data. So if we add color red, color orange, color yellow, color green, and color blue, we can now say, instead of fill red, fill dot dot color. And now our instructions are much more concise. For each dot, draw the dot. Use the color in the data for that dot. Use the position in the data for that dot. If I add some more dots, then this code automatically updates to draw that additional dot. Now this code isn't tied to a specific thing, it's data driven now. I can just update the data and the results on screen will be updated in response.